Welcome to this discussion on the fundamental concept of chemical equilibrium. Chemical equilibrium is a critical concept in the study of chemistry, which describes the state at which the concentrations of reactants and products in a chemical reaction remain constant over time. When a chemical reaction occurs, the reactants are transformed into products, and the concentrations of each compound change as the reaction progresses. At some point, the rate of the forward reaction becomes equal to the rate of the reverse reaction. This is called dynamic equilibrium, which describes a situation where the concentrations of the reactants and products remain constant over time. One of the key factors that determine the position of equilibrium is the reaction quotient, or Q. This is similar to the equilibrium constant, K, but instead of measuring the concentrations of products and reactants at equilibrium, it measures the concentrations of reactants and products at any point during the reaction. When Q is greater than K, the reaction proceeds in the reverse direction, while when Q is less than K, the reaction proceeds in the forward direction. When Q is equal to K, the system is at equilibrium. Le Chatelier's principle is another critical concept in chemical equilibrium. This principle states that if a system at equilibrium is subjected to a change in temperature, pressure, or concentration of reactants or products, the system will shift to a new equilibrium position to counteract the change. For example, if the concentration of reactants is increased, the system will shift in the forward direction to reduce the concentration of reactants and re-establish equilibrium. Another factor that influences chemical equilibrium is the effect of a catalyst. A catalyst is a substance that speeds up the rate of a chemical reaction without being consumed itself. While a catalyst does not affect the position of equilibrium, it can speed up the rate at which equilibrium is achieved. The concept of chemical equilibrium is used in many areas of chemistry, including in the study of acid-base reactions, solubility, and redox reactions. For example, the pH of a solution is related to the concentration of hydrogen ions in the solution, which is influenced by the position of equilibrium of an acid-base reaction. In summary, chemical equilibrium is a crucial concept in the study of chemistry, describing the state at which the concentrations of reactants and products remain constant over time. The position of equilibrium is influenced by a variety of factors, including the reaction quotient, Le Chatelier's principle, and the effect of a catalyst. Understanding chemical equilibrium is critical for understanding a wide range of chemical reactions and processes.